Welcome everybody to this AP review video on AP Unit 9, Inheritance. Um, so this is a unit from the AP content that I've covered in two of my courses. A lot of the content from this AP unit comes from the Computer Science 30S unit called Classes and the Computer Science 40S unit called Advanced Classes. Let's get started. So introducing this unit from the AP curriculum. Using Java, this, as I mentioned, has already been covered in 30S and 40S in previous units, essentially on classes. It goes over the concept of inheritance and the concept of association. So how classes can be formed into hierarchies and how that can be used to define behaviors and attributes and properties and subclasses and superclasses, and all of that content is going to come out in this review. So here you can see the specific section that this is about, the big idea of modularity from the AP curriculum, and the specific 9.1 through 9.7 content areas that it covers. All right. For the weighting of the AP exam, Unit 9 Inheritance is between 5 to 10% of the weighting for the AP exam itself. All right, so let's take a look at AP topic 9.1, which is creating superclasses and subclasses. What does this mean? So specifically, this is outlined in the AP curriculum as follows. You can read it there if you'd like, about class hierarchies, about subclasses, about the is-a relationship, and the keyword extends. But let's see how this was covered in both Computer Science 30S and Computer Science 40S. So one of the more powerful features of object-oriented programming is the concept of inheritance, which borrows its idea from biology, where children inherit traits from their parents. In other words, one class passes on the properties and the methods to another class, therefore not requiring that other class to write that code. It's just passed on. And then those new classes will then add new properties and new methods to improve on the original class. And this is sometimes known simply as a simple is-a relationship between two classes. So you have a child class, you have a parent class. You have the subclass, you have the superclass. In Java, the keyword extends implements the inheritance or the is-a relationship. And all these types of words and this vocabulary is part of that concept moving forward. Two types of relationship, the is-a also relates to the has-a relationship. This is sometimes just known simply as association, where one class associates with another, or usage. One class just uses the other class. So this is a much simpler relationship than inheritance, where we just have one class associating with another. Now, this can get more complicated. There's things like different types of association, and then there's even things like composition. But let's just look at it as simple is-a, has-a relationship. So in this diagram, you can see that B is an A. You can also see that E has a G, okay? So the E class associates with the G class. The B class inherits from the A class. The D class inherits from the B class, which inherits from the A class. So we can also use words like parent, child, grandparent. You can use the word siblings. For example, class D and class E are siblings. Those two classes associate with each other in the sense that they both inherit from the same parent. Stuff like that. All right. So now you have some of the vocabulary down, reviewing what it means to inherit. We can also apply this to things like, eventually, things like UML diagrams, or just ways you can identify a class with its properties and its methods and encapsulation, whether those methods and properties are public or whether they're private. And then connecting that, we can eventually write code. Like here you can see student extends person, where that keyword extends is what initiates the inheritance. So you can think of the word extends simply as is-a, right? A student is a person, right? So that's a way you can kind of think how this could be implemented. So then you have your properties and you have your methods, plus all your inherited properties and methods. So here you can see in the example we did in the 30S and in the 40S class, we rewrote through inheritance things like constructors so that we could incorporate the inheritance. We use the keyword super, and super, as you'll see later in this content, is a reference to the superclass or the parent class, or in C# it's called the base class. Plus, you can also use the keyword this, as previously covered in a previous review session, as an explicit reference to the class properties specifically. All right, so here you can see four classes: person, student, teacher, husky, and the relationship between those classes. So a student is a person. A husky is a student, therefore a husky is also a person. A teacher is a person, and a teacher has a student. So that's a relationship that has association and inheritance all combining. You can see a more fleshed out version of that diagram below that, where I now have also included things like the properties and the methods, moving that diagram closer to a more formal UML style of diagram. You can also see, if you go back and look at the example of this, the code that was applied to that. So how the husky class extends the student class. So classes can pass data and relate to each other through the is-a inheritance relationship or through the has-a association/composition relationship. Those are the two basic relationships: is-a, has-a, inheritance, association. So you can look back in the 30S content and in the 30S examples to see lots of different examples of this. If you're watching this review video and you weren't in my class, you can find links to the review videos or to the videos when I taught these lessons in my Computer Science 30S or my Computer Science 40S if you need a little more than a review, if you need to relearn these concepts. All right, let's move to topic 9.2 of this unit, writing constructors for subclasses. And here you can see, you can take the time to read through the AP curriculum, specifically what it says about this in sub-details of section 9.2. Let's review. So in the 30S course, we eventually made a method called born that we then rewrote into what's called a constructor method. I also remind students in that 30S class that you actually see this code even in the Computer Science 20S course, although you don't understand it at the time, as the line random equals new random, how that new random is actually calling a method. With the round brackets, that's your clue. That method is known as a constructor method. Constructor methods hold these properties. They have the same name, the method, as the class itself. This includes starting the method name with a capital letter. And, excuse me, most importantly about constructor methods, they have no return type, not even the word void. This is what defines them as constructor methods. Constructor methods are called when a class is used to instantiate an object. And again, you can look back in this review section and see examples of, for example, this being a person constructor of the person class. Constructors that have no parameters are known as default constructors. Okay, and as I said, constructor methods are automatically invoked or automatically called when you turn a class into an object. In other words, when you instantiate an object. And here you can see that broken down. The person, the class, person with a lowercase p, the name of the object, equals new. The keyword new initiates new memory. And then the call to the constructor method person. So here you can see it's a method with the same name as the class, including the capital letter. And the two round brackets implies that a method is being called. Happens to be the default constructor because we don't pass it any parameters. But constructors can be overloaded. In other words, you can write more than one constructor. You can add parameters. Like here you see an example of a constructor with a parameter. You can also see that this is also a good place to use the keyword this when you have overloaded constructors, so you can make explicit references and explicit way to not have a name conflict between the name of a parameter and the name of a property of the class. By using the keyword this, you can make an explicit reference to a property rather than be confused with the property, or pardon me, the parameter that has the same name. And again, I've already covered this in a previous AP review session, but you can look back at that, and you can also look at, if you need reteaching, you can look at the 30S and the 40S units on classes to get a better idea of this if you feel that's necessary. All right, moving on to AP topic 9.3, overriding methods. So this is really about methods, and about methods as it relates to classes, and what the keyword override, which is different than the keyword overload a method, and what that means. So overloading a method means two methods with the same name but different parameters. Overriding a method means you have the same name of a method as a method that was inherited from its parent class. And when you create a method with the same name as the method it's overriding, or that it's inheriting, it overrides that method. In other words, when you call it from the child class, it will go to the method that overrides the one from the parent class. And you can see examples of this in both the 30 and the 40S units on classes, where we used a talk method, and then we overrided that talk method of person in our student class, so that when the student calls the talk method, it uses the overridden method from its own class. Okay? And this also relates to the idea of public and private, which we've already also covered in a previous AP review lesson, how public and private are used. And now when you incorporate inheritance into that, you can think about the public and private as it relates to the class it's inheriting from. So here you can see a little video of that, right? So think of it, the analogy I use here is like a building inside of a building, where public and private and how it relates to that through inheritance. All right, moving on to AP topic 9.4, the keyword super. So here you can see, as it's defined in section 9.4, what the keyword super means as it relates to inheritance and the super class. So as I've already said, this is related to the is-a relationship of one class inheriting from another. Since we've already seen these slides, we want to focus on the specifics of how the keyword super is used to make a reference to that superclass. So that's the idea. The keyword super is referencing its superclass. So for example, this code you see on the screen right now is a class called student. Student inherits from person. So a student is a person. In the student constructor, you see the keyword super.isMale. What that's doing is it's accessing the isMale property of its superclass, which in this class case is the person class. You also see super.birthday. What's happening there is it's calling a method from its superclass person, okay, or its parent class. Don't get too lost in all the vocabulary. Grasp the concept of inheritance and how that keyword super can be used in your code to make reference to the super or the parent class. All right, let's move on to topic 9.5, creating references using those hierarchies between classes. So again, here's the breakdown about the is-a and the has-a relationships. In the curriculum breakdown, they talk about class S is a version of class T and how that kind of relates. So you can kind of start to process that vocabulary at the AP level. And let's introduce the idea of the word polymorphism. Polymorphism comes from the Greek word poly, which means many, and morph, which means form or shape. And polymorphism comes from biology, where an organism or species can have more than one form. For example, a butterfly and a moth. Well, this has a similar meaning in computer science, but in computer science, and specifically object-oriented programming, polymorphism is when a parent class reference is used to refer to a child class object. So we can look at this, which was covered briefly in Computer Science 30S, and then further expanded on in Computer Science 40S. So this is an example from Computer Science 40S, where we have class doctor extending person, and then we have other classes extending person. They're all extending, so lots of child objects inheriting from a parent object. We have the high school class inheriting from the student class, which inherits from the person class. We have the computer science teacher class inheriting from the teacher class, which inherits from the person class. We have the Mr. Walks class inheriting from the computer science teacher class, which inherits from the teacher class, which inherits from the person class. And all those classes inherit from the object class. So what the idea is, then all of those classes can be used in a polymorphic way, which leads into topic 9.6, polymorphism, and how that's part of the AP curriculum. So here you can see how it incorporates that, and yes, it does talk about the object class as part of that, which is something that's covered in Computer Science 40S. And we can now look at topic 9.7, the object superclass. So how does that relate the java.language, java.lang object class as the parent class of all classes in Java? Well, let's look at how we reviewed that in Computer Science 40S. So one thing we talked about was the use of packages, or in other words, namespaces, to organize classes so you don't have two classes having a name conflict. Think of it like a directory. Think of it like a folder structure, okay? Then from there, we talked about the object class. How the object class is the superclass of all objects in Java, including arrays, that inherit from that. And built into that object are several methods, 3 of which we looked at in detail in the 40S course: the equals method, the toString method, and the clone method. And here you can see them listed specifically. Now there are more methods in the object class than that, like finalize, which we did cover a little bit when we looked at collections, plus get class, a bunch of notify and wait methods which have to do with threading. That really wasn't something we covered and really isn't part of this discussion. But the idea that I encouraged in that 40S class is to always override those methods as just a sort of natural progression when you're writing classes. So we did that. We modified a template so that we always kind of overrode toString equals and clone, just to learn about the importance of those specific methods. In that, we also tied in a little keyword, the instance of operator. Just a little thing here, a little bonus, how instance of takes an object on the left, okay, on the left side, and the type, the class type on the right, in other words, the name of a class on the right, the name of an object on the left, and determines through a Boolean, true or false, did that object essentially come from that class? Is it an object of that type? So that's what instance of essentially is useful for. It's just a little operator that you can use for that. And here you can see it in action in our 40S example, plus the toString and the equals method. All right, let's summarize Unit 9 of the AP curriculum, Inheritance. So this was what we started out at the beginning of this video looking at, the specifics of how this is covered in the AP curriculum. Here is section 9.1 to 9.7, creating superclasses and subclasses, writing constructors for subclasses, overriding methods, the super keyword, creating references using inheritance hierarchies, polymorphism, and the object superclass. All right, here's an example of a type of AP exam question that covers this section 9 from the curriculum. So you have a class definition, public class thing, okay? So we have public class thing, and we have a method, public void calc, taking a parameter n to n. You can see it does a little logic with n. We see a second class, public class thing2, extends thing1. It also has a method, public calc. That is an override method. So it's overriding the calc method that it inherited from thing1, and it has its own logic. Then the question goes on to say that we have thing1 t equals new thing2 t.calc2. So what would be printed as a result? So let's break down how this kind of question would be solved, right? So the second class thing2 uses the calc method to add 2 to the past parameter. So you can see that right here, right? You see n plus equals 2. It's adding to 2. However, the second class thing2 before outputting calls its superclass calc method. So although this method is overriding, it is going back up to here and calling that, okay? And in that override method, it outputs n for the first time. So the n value multiplied by 3 is being outputted, okay? So if you think about that, when it calls that overrided method, it passes it a 2, okay? So it first adds 2 to it, making it 4. Then it calls the overridden method, takes that 4, multiplies it by 3, generating 12, which it outputs first. It's a print, not a print line. And then it immediately goes back to where it was called and outputs n, which is 4. Therefore, we are outputting a 12 immediately by a 4, which gives the correct answer as answer D in this case. And that's it. That's it for this review of AP Unit 9 Inheritance. Like and follow, and email me if you have any questions about anything that comes from this unit. Have a great day.